I welcome Akshay Bahadur for this podcast. This is a kind of a podcast where I'm not doing with a GD. I'm doing with a common person, a common developer who has that community hustle. Anywhere you say Akshay Bahadur, there will be one guy who will be knowing it. If you don't know, cause trust me, you're not attended any of the webinars, or else you're not be in the community at all. That's the amount of influence this man has. You know, all started out as a budding engineer in this bachelor's life. I know a little bit about him because I have attended not that many amount of webinars or the not a podcast. This is the first podcast I think from my side. You know, I've attended most of his webinars, and I feel that he has a unique approach to a problem statement. And the current problem statement which he's working, he thought he could have had completed it in two weeks or so, or else it would have been like a 2 days of collection of data and just worked out on the algorithm. But now it's a whole new level of story. It's not being solved now. It's all about his approaches which just keep changing. So I want to demystify all these things with him. So it's an honor for me to have Akshay Bahadur on my podcast. And yes, we'll be demystifying a lot.
Mm. Thank you so much for inviting me. I believe this is, I think, the first podcast. So thanks to Vishwas for actually inviting me. And I think over the last couple of months, I have not really been active, but there's a good opportunity for me to get back in the game. So I'm really looking forward to it. And I think Vishwas is very kind. I'm not really that influential or interesting, but thank you so much for that very generous introduction.
Yeah, let's just start with it. Akshay Bahadur,
Yeah.
Semi, your journey as an undergraduate student, how all these things happened, the building of the actual Akshay Bahadur.
So, okay, interesting question. So, this journey started in undergrad. I did undergrad from Symbiosis Institute of Technology in Pune, and as most of the students in India, I did my bachelor's because I had nothing else to do. So, because I had no idea what I wanted to do in life, I was like, let's do this, and then probably I will figure myself out maybe in the 4 years of engineering. So that happened. Luckily, I made some really good friends, really influential people who are friends with me till this date. And they have been they have inspired me to explore this journey. Um, so then, fast forward to my final year, I got a job opportunity to work as a Java developer at a company in Pune itself. NetTracker Technologies, we were working mostly in telecom. And that was really I mean, of course, the at that time Java development was really, it has been in Java development was a bit old, but I really enjoyed working there. I had a really good experience, and at the same time I felt that I needed to learn more. So I felt that I needed to challenge myself a bit more because I was young at that time, and I believe that, maybe if I could get some more insights, I could probably just wanted to explore. So me and a couple of my other friends, like Raghav, he's my roommate as well. So we started working on different technologies. So we did a bit of IoT just for fun, and it turned out well for us. Then I took on, so then we did a bit of blockchain as well, just for our own reference. And then at the end, I started with machine learning. This is around 2017, and I found it really interesting because it's a blend of blend of computer science and mathematics. So I really found that interesting, and I did some courses online. So during part of that, what I did was I actually started making some small applications, and this was for my own learning. So I used to maybe study for the entire week. We had a week duration, and then let's say in the week I studied about gradient descent. So then I applied that over the weekend on a data set that I could get from Kaggle or in any other data source. And then I found it really interesting because I was able to not only learn but also implement these concepts. And then I started posting them because I wanted, first of all, me to be noticed, and then I also wanted other people who are in similar situations can probably look at my code and see, okay, maybe this is where they went wrong. So, and then that really helped, like that cascaded me into. I mean, got a lot of got to know a lot of people through that. I got to meet a lot of great mentors through that. And that was like how the journey started. So it was more of like self-learning. And of course, I had support from my friends and my teachers. So that really was very helpful.
Fast forwarding that you are a professional now, professional with a
Yeah.
GDE tag. I don't care whether you have good amount of certifications or else you have good amount of people as your reference. I just want to know what's your actual work that you have done. Anytime when anybody asks me what's your package, where do you get placed, I get irritated. When somebody asks me what project did you do, that really fascinates me. No, what was that actual motivation to do such good projects and deploying it and publishing it? Of course, you have got an amazing website, but what really motivated you? Like to just keep doing the projects back and back and back. And when I see your website, I feel like, man, I should have met him like 2 years before or 3 years before. I could have
Yeah.
demystified something.
I think there's a lot of interesting stuff that's going on in machine learning. And to be honest, I am really envious of you or any other who's starting out because uh, so when I was starting out with machine learning, the field was open for me. Like I could go into computer vision, I could go into NLP, I could go into both, I could go into data analysis. So that journey is really fascinating because more than where I am right now, I was more satisfied or more intrigued by the whole journey. So I am envy of everyone who are starting that journey or on that journey because I feel that probably I have reached a point where when I look back, this was fun, but I really enjoyed the journey part, right? So it's not that you started. I mean, if you had started 2 years back, you would be in a better position. I feel that what you guys could do, I could never do it. You guys can start your journey, or you can continue this journey, or you're still at initial stages. And what, no matter what I do, I can never go back in time and live that journey once again because the journey is very rewarding. Trust me. So that's one. Second is, of course, package money is something that I mean, some people consider it as success, and I lie if I say that I don't really care about money because once you have money, you can give. I mean, you can have a good lifestyle. You can give a good lifestyle to your family. But at the same time, I believe that at this age, like anybody who's starting out, maybe if they are, you know, maybe in their late 20s or early 30s, it's more about getting to learn. And once you are able to build yourself as, or once you are able to give this sort of validation or credibility to your work, I think money is going to come eventually. So when I started out as a Java developer, my pay was very less. Like it was good, but I was really satisfied, right? So the world was new to me. Like I could go and do anything that I wanted to, right? And now I'm earning decent amount of money, but my responsibilities have increased. So at work, I'm supposed to do a certain tasks, whereas when I was starting out, I could finish work till at 3 o'clock, and then 3 to 5 or 6 or 8, I could do whatever I wanted to. I could learn physics, I could learn literature, I could learn mathematics. Now it becomes difficult because now I have responsibilities, and I am more easily replaceable by other people. So it's more about the journey. It's more about the fact that you can. Uh, um, I mean, money is good, but it's more important that once you have that credibility, and that will only come with work, with the publish. I mean, with the papers you publish, or with the project that you do, or just whatever you learn. So I think that's interesting stuff. And talking about GD, so GD programs, I had no idea what GD was. So these projects that I did are only for my own learning, and I found them. And the good thing is that I started sharing them, so people started liking it. So I had no intention of actually publishing or any intention of monetizing any of these projects. I did it for fun, so maybe I read some, and then of course you can read other papers as well. You can see other people implementation, use it, don't copy it, use it in some other way, or even if you want to copy it, probably cite them, cite those papers or those other GitHub repositories. So that was the project part. So for the GD journey, I had no idea what GD was actually. And I know somebody from Google, they reached out to me saying that there's a good program for you. And I was like, fine, it looked interesting. And it was like, okay, fine, I'll give it. So I applied for the first time. I could not be selected because I had sort of like they mentioned that they want people to have this qualities, and I did not have a bunch of those. So I was like, it's fine, but overall they mentioned will make sense. So basically, what I would previously what I did was I used to write these documentations, technical documentation, which I thought would be good enough for everyone. But then they explained for a new person, for somebody who's beginning, they'll probably not understand how a README works in GitHub. So it's better to have a blog which breaks down the code or breaks on your methodology, and that will become easier to be accessible to more people. And then I realized that therefore I started writing some of my own blogs. So yeah, I mean that was how the journey started. I failed once, then I for 1 year I prepared, not specifically for GD, but the points that they mentioned made sense. So I prepared accordingly, and then I applied after 1 year, and I got in. So that was how you go through that process.
You know, speaking of the blogs and posting videos on YouTube, of course, there are many factors. But what do you think that this is the main factor that a GD needs to have in his life? If he's a GD, let me just say you are a GD in ML now. So what are those
Hmm.
factors that you feel like if somebody is going to be a GD in the future, what should be the actual thing that he needs to have in order to be that one person who is really suitable for that role?
I think so. There are a bunch of things, but if I have to point out one which is most important according to me, I believe it's and it's not just for GD. It's I believe for any role that you want to achieve or any achievement that you want to have. It's consistency. So by consistency, I mean that you need to put in the effort. Let's say if I made a project, for example, let's talk about projects. So let's say if I made a project which is the best project for self-driving car. Probably not even Tesla has that. And I put it out on GitHub. And that's my first and my only project. Now and then I stopped doing it for whatever reason, right? So that one project will make a lot of sense. It will have a lot of information, but it will not give you credibility because it could be a one-shot wonder, right? Or maybe I could have copied it from somewhere. Or but if you do it consistently, so maybe if you improve that same implementation, if you improve that, or probably you make a paper out of it, or basically it's putting in efforts, making, or maybe you can make several small projects for your own learning, but that will actually show me कि bhai, this guy is interested. He's not doing it just for the sake of doing it. He's interested, like he is genuinely interested in the field, and he wants to uh, perform any research or whatever he wants to do. He is serious about this. So consistency is definitely the most important according to me. Second, that I believe is they should have the ability of or I will say they should have that motivation behind doing original work. So by original, I mean that don't publish a paper or something, but even if you are using somebody else's work, what else? Like what's the original thing that you're adding to it, and that will be your that will add value to you. So, and then of course the third I think is also how you present yourself, because as a GD member we are invited to multiple conferences. So it's important to present your thoughts properly and have a good hold on. I mean, of course, you can learn these over time when you give a lot of sessions, but this is also important in how you conduct yourself and how you talk to the people, convey your ideas, convey your thoughts. I think that's also very important.
Speaking of all these, we talked a little bit professional here, I think, about the professionalism
Yeah.
of being what contributing to the community and also about your journey as a profession. No,
Yeah.
I just want to ask very technically, is computer vision really hard to learn, or else is it hard to develop something on computer vision? What is your thought process on this?
So for computer vision, I'll say that it's not. So there are two things, right? So there are two things which I'll consider. So first is difficult, and second thing is so basically there are two things, right? So if something is easy or if something is simple, okay. So by simple, I mean that we know the methodology. So let's say if I say that I want to lose weight, for example, the whole process is simple. That is, if we eat less and if we spend more calories, we definitely know that we lose weight. So the process is simple, but it is not easy because we have to be consistently doing it for 3 months, 6 months, 10 months, right? So the process is not easy, but it is simple. Similarly, in computer vision, the process is simple. We have books, we have blogs. You will also find resources for free on the internet, but you have to like you have to put in the effort to go ahead and study. You have to put in the effort to do some assignments, or you have to put in the effort to actually use what you have learned in real life, uh, apart from just the books. So it's simple, but it is not easy. So you have to put in the effort. However, there are a lot of blogs available. So personally, I follow PyMeth Search, which is a great blog on OpenCV. We have OpenCV, Learn OpenCV as well, which performs the. Uh, then there's also an OpenCV initiative by Satya Malik, who um, is kind of like the open source guru for computer vision. So and they also give you some open CV kits and all, which helps you in the development process. So we have lots of sources available on the internet, which I personally follow. And so I did not have computer vision as a subject in my college. Image processing was not even an option for computer science students. So one of my friends was in electronics and they had image processing. So I was interested, so I learned from him, like just the basics of image processing. What do we mean by convolutions, or what do we mean by blurring, Gaussian blur, things like that. And then you can find all these on the internet as well. So it's more of your motivation, but it's not that difficult. It's the process is simple.
Akshay, I just want to ask like this. I think it's a very silly question, but I want to ask this. What are the canonical problem statements that are still present in computer vision? Can be neural networks, the architecture of the neural networks, or some unsolved problem statement which really can be solved through computer vision, but people are like negligent towards the potentials of it. What are all those?
Yeah, so interesting question. So personally, and this is something that I have been, very vocal about as well. Is so I'll talk about India. Like so, basically, any problem that you want to solve should be very personal to us. Okay, so and it does not require. It does not mean that you have to solve using computer vision or machine learning or even computer science in general. You can do it however you want to, but the problems should be personal to you so that you feel motivated. But apart from that, if I were to get a choice, solving problems in computer vision, I will choose problems in India. So specifically problems in the field of healthcare, agriculture. These are the two main like subdivisions which I feel are really important because most of us, or I think almost all of us, are directly or indirectly affected by these. These fields. So if perhaps we do something in the field of healthcare, perhaps if you know Google AI lab is in Bangalore, and they're working on some really interesting use cases. So they are working on something called as diabetic retinotherapy, whereas given the image of a retina, you can predict whether the person has diabetes or will develop diabetes in the future or not. So that's a good use case, and it's very interesting. And Google is doing it for specifically for India. So that's one. Second um, is his agriculture. So maybe and because we have manual fields, can we automate some parts of it? Perhaps instead of going. So basically, what's happening right now is people use fertilizers and they use it in abundance. Because of course we are a big country, so we want to increase our food yield. But can we probably have sensors in the soil which could calculate the different levels of fertilizers and say that, perhaps we need this much, or maybe we can have sensors which can get the moisture level and then irrigate accordingly. Maybe we can even use machine learning for weeding out specific pests, so we don't have to spread pesticides throughout. We can do like a targeted killing of pests. And so these are like very interesting use case. But yeah, so I personally will feel that in the field of healthcare and agriculture, if we do something, even if we take a small step or if we do a minor change, it's going to have a very large impact on all of us.
Oh yeah, I always wanted to ask this question. You have also worked on IoT. I know that you had some projects on Raspberry Pis and everything.
Yeah.
But what are the benchmarks in computer vision that makes you feel like, of course, computer vision is somewhere else today? What are all those benchmarks that it can be on edge, on compute, or a cloud deployed one, anything, any benchmarks that has really told you, of course, computer vision has great potentials in it.
Very interesting. So recently, we might have seen, so computer vision earlier was most about these image processing techniques, right? And of course, makes sense. But the real potential of computer vision came, actually was magnified when machine learning, deep learning came into picture. So with deep learning, computer vision was enhanced, and we could now solve vision-based problems using this learning models that we develop. So I think that's a very major use case. Uh, Apart from that, I believe that now currently, like, I have not really explored it, but we have transformers for computer vision models, which so transformers really revolutionized NLP, because I am working on NLP a bit as well. So transformers has really kind of propelled us into this whole new dimension where NLP problems are not that difficult. For anything, we can use BERT embeddings and probably have a really good set of features that we would get from words. So I'm not sure about computer vision, but I believe I've read that if we could do something for, if transformers work really well for vision, it's going to be really helpful, because then you can just use these transformers or use these pre-existing models. So let's say if I have a small CPU, I will not worry about training it for millions of images, right? I have the pre-trained model, I just use it for myself. And then if I want to solve something for my own, I could do it pretty easily. So that's, I think, something that really motivates. Like, I think it's very interesting, and I would really want to try out some of these stuff going forward.
Akshay, which is harder, language or vision, NLP or computer vision?
So I'll say NLP is slightly more tricky to understand, because in an image, no matter what you do, your pixels can only be between 0 to 255. So that's the pixel intensity. And I can at most have three channels. I can have RGB, right? So red, green, blue. So I know that my sample space is limited to this condition. Whereas in NLP, it's not. So it's not limited, because let's say if I say half of a sentence, let's say my name is Dash. Now, if I have to predict, logically, if you think about it, there are multiple things that, like, there are millions of words that could actually take that place, right? Or maybe if so, that's just for English. What if we go for any other language, right? Whereas in images will be same whether it's taken in India or the US or Canada, any place. So computer vision, the problem statement is slightly like, we have a better understanding of our computer vision problem, because we know no matter what happens, we have a boundary. These problems are bounded in terms of the sample size. Whereas in an NLP based problem, it's slightly more tricky to understand. But um, both of them have an extreme end, because NLP has really easy problems as well, which you could not even use machine learning. You can directly do it by hand or by a simple heuristic. And there will be some problems in computer vision which are really, really tough, and not even a very sophisticated machine learning algorithm will be able to solve those. So there are extreme ends to both, but in general, like if we look at the average or the median of it, NLP is slightly more tricky to understand and slightly tricky to master. So yeah.
Yeah, when you told about Transformers, I recently did a podcast with Dennis Rothman. He's the first
Mm-hmm.
person who has written a book on Transformers. It was amazing when
Mm-hmm.
I heard about that. Because he really wants his readers to really go and fiddle around with the technology. Hugging Face would have been amazing, man. Hugging Face would have been
Correct.
so cool that just 3 lines of code, everything is done. You need not have to optimize anything.
Yeah.
It's like Pandas GUI for your NLP kind of a thing. It's so
Correct.
clean. And
Correct. Yeah.
yeah, he really wants us. And we talked a lot on spirituality and more of a things like that. You can go and watch this podcast. And,
Mm.
it's an amazing podcast. If you
Yeah.
want to really go and viewers, just go and watch it. It's an amazing podcast. Yeah, most of your
Mm.
project that you do is end to end. That is from deploying the
Mm.
processing, the pre-processing, and to the deploying it on an application, or else building something as a Python application is also a very, very tough challenge. What's your approach when you solve your problem statements like that? There's a huge demand for it
Yeah.
today because everybody can never do it. There are multiple models built, but not all models get deployed. But what's your approach when you're giving an end-to-end
Correct.
solution with a computer vision?
So for the first thing that I mean, I already mentioned is that you should resonate with the problem you're trying to solve. So your problem, even if it's like a business problem, you should have some sort of an understanding of why am I doing this. So let's say if I say that I want to detect cats and dogs, it's important to understand why am I doing that. Like how what we already have a bunch of implementations already out there, like millions of implementations for cat and dog classification. So if we go ahead and do one more, what's the difference? Like why am I doing it? So if it's for learning, then at least we should have an idea that okay, it's for learning. So even if we make mistakes, it's for the best because we'll get to learn. Or we could also think of probably if you are doing it for some social cause, then you should have that motivation that you are doing it for the community, you're doing it for the specially abled people. So that will motivate you. Or if you are doing it for a company, maybe if you want to deploy a search based like reverse search engine for Amazon, we should know okay, we are going to deploy it for millions of people. So I should like my model should be fast enough, it should be scalable enough to actually be used by millions of people. So now if so we should at least spend time on understanding the problem. Like we should have okay, maybe um, so if I have the expectation that I if I develop a if I want to develop like a search engine, a reverse image based search engine, I cannot expect it to be doing something for the like differentially abled community, right? Because that's a different use case. So the use case should be very clear. Second is we should spend time on scoping the problem. So I cannot say that okay, within a week I'll develop this reverse search engine for Amazon and I will deploy it and then people will use it because within a week it will be very difficult. So you should follow the whole process. So maybe start from a POC, just a point of just a proof of concept. Then probably go ahead and get some insights from maybe some research papers, go ahead and discuss it with your seniors, with other people, and then have develop a model, benchmark it. By benchmarking, I mean perhaps you can either do like a manual test where you have people which are manually able to check whether your machine learning model is working correctly or not, and then maybe A/B testing where some people will have your model and then some people will have the actual running thing which is already running, and then we can see how much difference like is it affecting like is it making a positive impact on my sales or not, or am I getting more number of people to see these products or not. Sometimes what could also happen is that it could go down, maybe the model is so bad that people actually don't buy anything. So that's an indicator that okay, we probably missed out on something. Then we go back to the drawing board and develop the whole algorithm once again. So scoping is very important. So we can say that okay, we'll take 3 months, but you will do it end to end properly. So we have scoped our problem. So that's the second part. Third is we do enough literature review, and by literature review I mean that not just research papers, but you can also find some books. You can find some GitHub repositories, and it's because other people might have already done that, so you can use inspiration from those and probably use it for your own reference. So that's the third part. Fourth is, I believe that as a computer science graduate, it's important to not only build the model but to engineer the model. And by engineer the model I mean, as engineers you should think about everything from end to end, and everything in terms of modularity. You can, well, let's say if I want to leave my current job role, how easy will it be for the other person to come in and pick that task up, things like that. So once you have all of those things ready, it's important to then deploy the model, and then of course a bit of it is luck as well. So yeah, I think those are the steps that I definitely would recommend to follow.
So, Akshay, what are the key features that led to the evolution of deep learning to this stage? It's not an hype at all today. It's an hope.
Yeah,
If there is any
yeah.
problem statement, deep learning is in hope today. What are those key ideas that led to make it become an hope today?
Interesting. So I remember machine learning was a concept that was introduced in 1980s. So machine learning was, I think, formally introduced somewhere by 1980s by Tom Mitchell from Carnegie Mellon University. Like he played a very important role. But what really led to the advancement or the popularity, there are multiple factors to it. So I'll talk specifically about India. So in India, it became really popular in 2015, I believe, 15, 16. And this is the same time when India had good internet connection. So Geo was coming into the picture. 2017 was when Geo actually started giving free data to people. So around that time, we were like previously we had less bandwidth. So getting these online lectures were difficult for us. So then that was the first thing, right? So the time at which it boomed coincided with the internet capability that India had. Second, at the same time, we also had people who like computer science was booming, because if you see around 2000s or 1990s, mechanical engineering was really doing really well. Mechanical and civil engineering in India specifically were doing really well. So around 2010, 2015 was the time when computer science started. Computer science was already there, but in 2015, 16, a lot of companies from outside started coming to India, opening the development centers in India. So they wanted more and more people with good amount of knowledge. This coincided with the fact that machine learning was a next career option for people like data science. And then of course we had good internet connection that could enable at least me to not worry about going to a classroom to study. I could study from professors from from MIT, Stanford, out of my sofa or out of my bed or out of my table. So that really helped a lot of people. And at the same time, it's also became really clear that people were looking for options. So uh, I mean, when your father was working or when my father was working, their options were limited. Like government jobs were the kind of the norm back in the day. Now people are taking risks. They want to be paid for the skills that they have and not some other factors. So the attitude changed for people in India, and this should have also happened for everywhere else. So I think this is like these are the factors. But if you look at the whole the kind of the roadmap for machine learning, the machine learning technically became very relevant to us here itself, because the compute power, like the amount of money that I will spend on compute has actually gone down a lot. So I can just right now I can just spin a collab environment on the internet for free, and I can do whatever I want to, and I don't need to pay anything. My laptop will be safe. Um, Again, now we have more and more data. Earlier we had to collect our own data. Probably we have to spend more and more time on that, which meant that if people had a motivation, they'll go for it. If for some reason they don't have motivation, they might not go for that, or probably they'll start but not finish that task. So that played a really important part. So I think these are the things. And of course we had a lot of great revolution like development. So deep learning became really popular, which is like saying which is perhaps an easier way of getting started with AI, because you have everything as a package. So getting all of those information at the right time kind of propelled this whole field to where it is right now.
Yeah, when I speak of your projects, it's a stage released version. I'm not joking because
Mm.
you have told it in many webinars that you wanted to do this in 2 weeks or 3 weeks, but it is taking a long time. The same sign language project which you have taken now.
Yeah,
You know, you have said that,
correct.
but looking at the software architecture which has evolved over a course of time, let me say TensorFlow 2.0, I think it's a new disruption apart from what it had. Because when you see the potentials of it, functions, eager execution, of course, eager execution was there, but like in a very fast fashion, I have never seen TensorFlow as potential as what we are seeing today. Like, what do you feel
Mm.
about the evolution of the software architecture? I know you're not that old to answer this because you are still in your 20s, and I
Yeah.
can't I can't say you talk like a 60-year-old man who has seen the software engineering evolving. But I want your view on how the software engineering has evolved. Are we really underestimating the potentials of neural network tomorrow? Because this question is related to the very next question that I'll be asking.
So I believe that of course what you're saying makes sense. So TensorFlow initially was developed for Google to be used internally, right? So they wanted to use as an internal product, and they have a lot of these other projects which are internal, which are not released for the common public. But what we saw in machine learning, and if you also look at some of my previous code, I did it using NumPy. So NumPy, I had to write everything down. So let's say even if it's like a back propagation, I have to write the differential of softmax so that I could perform all these steps. Well, of course, that was fun. But then as we go ahead and as we move to more difficult problems, that becomes an overhead, and that maintaining that also becomes difficult because I have to. These are now my moving parts, and if I'm working on a very difficult problem, I have to take care of all of these moving parts. So that's one thing. So then when TensorFlow came into picture, it was not really evolved. I think I remember 1.4 or 1.5 with eager execution and all, and we preferred Keras because Keras was a easier. You can just write 4 or 5 lines of code, and we will have the model ready, and then everything else was kind of just on top of that. So yeah, and then when 2.0 was released for TensorFlow, it had something for everyone. So Keras was formerly a part of TensorFlow. So if you're a starter or a beginner, you can just use ta.keras and then go ahead and do whatever you want to. If you are somebody who is slightly advanced, you can use directly TensorFlow and then use your own custom training modules on top of that. Or if you are maybe somebody who is working on distributed systems, you can use their distribution
Yes.
strategy. So you can train it on a cluster of nodes. That's first. So it has something for everyone, I believe. And then this was specifically developed for open source. This was specifically developed for the ease of people. So that's something that was really interesting. And not just TensorFlow, PyTorch as well. Like I have not used PyTorch, but if you see a lot of researchers in the recent years, especially Microsoft researchers have stuck to PyTorch because both of these has their own advantages and disadvantages. But it doesn't matter. You can choose any, and you will still the concepts remain the same. You will still be able to do whatever you want to. And then of course there is also cross collaboration. So you'll find same models or same architecture for both PyTorch and TensorFlow, and you can use them according to your preference.
Yeah, I always wanted to ask this for a professional who is in computer vision. Because what this question especially I've asked it to all the people who have authored and who are like above 50 years pro. I really didn't
Okay.
want I really wanted to get their insights also, but I want your insights to be very
Okay.
strongly saying, can neural networks be made to we solve to get the insights and the intent of a problem statement that we give it. Like, let me just say, I give it a scene and it has to say everything about it. It's just like human having a gaze of a second and it can really extract a lot. Can we build neural networks as good as a human being? That's my question, actually.
So that's interesting. But what
And
I
you can
also
also
want
talk
to
about
count,
intent and also the other forms of factors that we might be considering when we are building something as a neural network.
correct. So what you're saying makes sense. But I would want to slightly go a bit into. I'll talk a bit more about what I believe in. Like, this might not exactly align with your question, but I just feel that I would need to put it out there before I go ahead and answer your question. So in response to your question, you mentioned that can your network go ahead and build these very massive use cases and solve these problems. However, the main question is, do we actually want to? And by that I mean, after a period of time, the lines will blur out between what could be done and what should be done. So by that I mean, for example, um, somebody asked me this use case. So there are two incidents that happened. So one was when somebody asked me that they want to develop a system where students are sitting in a classroom and they are tracking they are monitoring all the possible scenarios, like how the student responds, and we can estimate whether the person is paying attention to the class or not, right? So it makes sense, like logically, if you think about it, of course you want to do that, but do we need to do it? Because as a student or as a child, you of course are supposed to learn, but at the same time your mind can wander, and that's something that all of us have done. And it's part of the childhood, right? So you cannot expect everyone to have all the attention at all the times. So can we do things which are ethically correct or not? And then of course it's a very wide statement. What ethical might be to you might not be ethical to me. Or for example, can we have this facial recognition technology to probably catch criminals on the run, or maybe when they're in the act? Can it be utilized for harming our privacy, right? So these things are important. So the answer is that at some point of time these lines will blur, and then we will have a lot of difficulties about our own privacy, our data privacy. um, so I believe that neural network has a lot of potential. We are still scratching the surface, and we have just started with with all the things that we could develop using machine learning, deep learning, and it has a lot of potential. But at the same time, there should be sort of ethical or a moral responsibility of everyone to be able to answer, like to be able to answerable to some community that, okay, if this is done, can it be used in something different? And should it be used in that way or not? So I believe that is something that I asked myself, but I don't have an answer to that yet. But yeah, that is something that we really need to figure out at sooner rather than later. So,
Say thank you so much for this amazing podcast. You know, it's my first podcast with a GDE. It's not with the old
thank
person,
you.
it's a young GDE. You know, thank you so much for giving such an
Mm,
amazing podcast. Just lovely talking to you. I think 15 minutes might be the recording. I don't know, but I really enjoyed it.
sure. I really had fun, and this was really amazing. And I have been working on a lot of interesting stuff recently, which I will share with you guys really soon. So if you see, like, I have stopped after sign language, I do not really do anything. So I think for the past 2 years or so, I haven't really got a chance to work on any interesting stuff because I did not really find the use case or the motivation behind it. But during the lockdown, I kind of thought that perhaps, okay, like I saw a lot of other people were doing really well, and I thought that it's good. And I really only want to share stuff on open source, which are mine and which makes sense. So I will really not want to do anything which is redundant. So over the lockdown, I did a lot of introspection, and I came up with a lot of use cases which I feel, and I got ahead and got those skills which are required. So I'll share that with you very soon. And if you want, I can share a small snippet of it pretty quickly. So I'll put it in the chat for you, Vishwas. You can look at it and you can let me know, if you liked it and if you want to go ahead and put that in the podcast, or you can just use it for your own reference. So thank you so much for that. And I will share that recording with. I'll share the project which I have been working on very soon. I'll share it to you in the chat, and you can probably share if you feel it's helpful. So let me check.
Yeah, I was thinking like
Okay.
you can you can also come for the part two, because bro, I really want to do a part two with you.
Yeah, I would love that. So I actually have a few things going on currently. So
Yeah, yeah,
by
fine, I
that I
can
mean
get
there are
it.
certain yeah. So yeah, so this is the link. If you want, you can have a look and let me know how to, and if you want to include that. So is it like a video podcast or an audio podcast?
Yeah, this is an oh, gymnatic lunch. Oh, fine. I think I need to share my screen here. Share my screen here.
Yeah, or maybe you can just add it at the end if you want to.
Yeah,
Like
yeah,
if
yeah.
it is a video one,
Yeah, it's
yeah,
the
because
video here. The video
yeah,
is
you can
here.
play it. Yeah. So basically,
Amazing.
it's doing yeah, it's doing these lunges, and based on how well you're doing it, if it's 100%, it means that the lunge, like the exercise, is done correctly. If it's not 100%, then your counter will not increase. So it's kind of like a real time, real time trainer for you, and then you can, depend. I
I
mean,
think
you
you have
can
not put it in
increase.
the. I think this is there in your website, right?
No, this is not there. So this is some.
Okay.
So if you look at, yeah, this is like I did, I think, couple of weeks back.
Okay, okay. It's
And
not in your
yeah,
website.
yeah, it's not in the website. It's the code is currently private right now because I'm still testing it out. And I'm thinking of
Sure.
having multiple exercises. So I'm thinking one of for like the most common ones. So that will take some amount of time, but I just thought that probably you'll enjoy it, and
Yeah.
if you want, you can share it.
Yeah,
So so
it's
yeah,
in the
so
screen share and it's recording. Yeah, of course it will be there.
yeah, so this is something that I did. I mean, because I was, I mean, everybody was trying to get fit at home, so I thought that okay, why don't we give this a try and probably see if I could build a trainer around this like whole thing or not. So yeah, so I have multiple things which I am currently working on. So perhaps in the part two, if you ever have that, we can talk about all those things as
Yeah,
well.
yeah,
So
sure.
very
Sure, I
okay.
think I'm
All right.
ready to do
Thank you.
part two with you. I'm ready to do part two with you. I was actually thinking, man, I didn't
Thank you.
demystify much a lot. So yeah, I think much more has to be demystified, friends. Trust me, Akshay Bahadur. You can't study about him in a day, man, because he has built himself from that long time. You can't really get to know about him in an hour of podcast. Probably I can do hundreds of podcasts with you. Thank you so much, brother. Thank you so much.
Thank you so much. Thank you so much for the podcast. Really enjoyed it.
Yeah.